Okay, we're beginning chapter 3, which is the basis of all of calculus, and that's all of the rules, opportunity to find instantaneous rate of change, speed, slope. All of these three conditions are done in a quick and dirty way using rules. But we're going to take an aside and still keep with the difference quotient. So here we start on section 3.1, tangent lines and derivative at a point. Derivative at a point is the inclusion of f prime of x, f prime of x. So we're starting first with y equals mx plus b. This is the standard, except I can't write today with, I'm getting form, which is the one that we require to construct a tangent line. So we're going to be using that. And in this course, to construct it, I'm going to use I equals m parenthesis x minus the x of 1 plus y's of 1, where my point is my x of 1, y's of 1, and my slope is the derivative at x value, prime of x of 1. And I'm going to use the prime notation because my slope is the derivative. All right. So we understand now that we've got to get it into the y equals mx plus b for the tangent line. And we understand that that's what I'm going to be using so that nobody gets confused. So in algebra, you need either 2 points or point and slope. And what we're doing is this one, point and slope, point and slope. And our slope, the derivative of the function x value of given point. And again, we'll be using y equals m parenthesis x minus that x of 1 plus the y's of 1. All right. So we're going to be again using the difference quotient as in algebra and as a limit as h approaches 0. The last time we'll use it. Sorry. So our slope is going to be at the value of the derivative, because this is the first exposure to derivative that was done by mathematicians long time ago, as to narrowing it down till h is 0 and finding a limit. And in our case, it's instantaneous rate of change. All right. So this is leading you by the hand, and this is our first example, and you'll have one on your homework as well. So it says for A, they want f of x plus h for the function, the linear function. So this means I have 5x plus h minus 3. So I distribute, I get this value. And then they want the function of x plus h minus the original function. So this guy I already know, minus the original function. And then we're going to cancel out additive inverses. And I'm left with 5h. Sorry, I was going to put an x, and I apologize. And then they want the difference and we've done this portion here. Proves derivative of a linear function is slope. What this exercise proves. And that's what we want to prove, right? That it is that derivative. Well, we're not doing all the fancy stuff yet, but we will, I promise. Okay, so here we have a rational function, 1 over x, and the slope at a negative 1 over a squared is going to be this slope here. This is negative 1 over a, and here the slope is negative 1. And they're just showing you how to do the tangent line at a given point as a process. But what we're looking at is the following. We're looking at the slope of a curve, y equals f of x, at the point P, x of O, and the functional value of x of O is the number, the limit of the difference quotient. So the tangent line to the curve is then at that slope. And we just did that. So we first, in calculus, you've got to make sure there's not a typo, especially if I'm typing something. You have to make sure the point exists on the function. And that's what I wrote. Need a point that lies on the function. Find the derivative of that function. Insert the value of x point in the given point to find the slope. So we're talking about f prime of that x of 1 value. And then use it for the equation of the line. So those are the steps we're going to take. It's a little bit just math for now. And again, we'll get to the quick and dirties very quickly. Is everybody comfortable with that? Everybody breathing? All right, so let's do this guy right here. Find the equation of the tangent line to the curve at the given point. Then sketch the curve and the tangent line together. And we're going to do it via calculator, because on your homework, you'll choose the appropriate line. Okay? Is everybody comfortable with that? All right. So we want to drop in what we know. We know that y equals 8 times the square root of 1, and therefore y is 8. So we've got a truism here. Okay. So, and we want that point to work. So we verified that the point exists on the graph. Is everybody comfortable with that? Okay. Again, it's a safeguard for you on my typing. That was our first step. We got to make sure it works. Okay, our next step is to take the derivative. And that means that we're talking the slope is as h approaches 0 of f of x plus h minus the f of x all over h. Okay, so here we go. Now I'm going to put in 8 square roots of x plus h minus 8 square roots of x over h. Does everybody agree? All right, so what we're going to do is multiply by conjugate so that we can get h approaches 0 on the bottom and x to cancel out in the numerator. Is everybody comfortable with that? All right, all right. Here we go. So if I multiply by 1, I've not altered the function. Because if I multiply on the top and the bottom, it's 1. Everything is the same, just looks a little different. Is everybody comfortable with that? All right, all right. And when I do this math, it's going to be 64x plus h minus 64x. Sorry, forgot my parenthesis. I apologize. All over h times this mess. Everybody good? Okay, here we go. When I do the distributive property, and I'm just going to go across, 64x plus 64h minus 64x all over h times the mess. All right, so when I do that, I'm going to have x go away, and I have only an h. Is everybody comfortable with that? Okay. When I do that, I can cancel, because it's a multiplication process, that I can cancel the h's. And now I'm setting everything to, I'm taking the limit now that h is 0. Is everybody comfortable? Good. So I'm going to have 64 over 16 square roots of x. All right. 16 into 64 is 4, 5, what is it? 6? 64, so it's going to be 4. And x is 1, right? So my slope is 4. Did everybody see what I did? Did I do good math? Okay, you know I stink, so, all right. Now we're going to construct the line. We have the point, 1 and 8, and then we have our slope is 4. Everybody breathing? Okay. So now I'm doing y equals m parenthesis x minus that x of 1 plus y's of 1. Y equals, and my slope is 4, and it was positive, no negative, so I'm good. X minus, and my point is 1 plus 8. Y equals distributive property 4x minus 4 plus 8. Y equals 4x plus 4. I think I did good math. Everybody agree? Okay, now we're going to use our calculator, and I've got to boot it up. There it is. Deal. All right, so I'm going to go into my y equals. I'm going to clear everything, and I'm going to enter my original function, which was 8 square roots of x. Is that correct? And then for the second entry, I'm going to enter the 4x plus 4. I'm going to hit zoom 6. And there it is. So I'm going to have to do a little bit more math on my window. I'm going to decrease that. I'm going to increase that. I'm going to decrease that. And I'm going to increase this. Let's see if that looks better. Let's see. No, I want it higher. What did I do? Oh, I had a 5 instead of a -5. Sorry. I'm going, what? And I need more than that. There we are. Okay. Everybody got that? Okay, now we want to make sure the tangent point means that the line touches the function at 1/8, right? 1/8. We got to make sure. So we're going to go second calc, and we're going to go value, and we're going to enter 1. And it says for the blue line, it's 8. If I move down, it says for the red line, it is 8. Everybody know how to do that on their calculators? Everybody good? All righty then. We are good. I'm going to stop right here. That's 17 minutes, so I'll stop right there.